Take a good look at this sleek, dart-like aircraft. Its pointed nose, swept-back wings, and streamlined fuselage might seem like something out of a sci-fi movie. But this is very real. This is the XB-1, Boom Technologies' supersonic demonstrator. It's designed to fly faster than the speed of sound, ushering in a new era of commercial air travel. And it's not just a concept. It's scheduled to take its first flight next year. While aviation giants Boeing and Lockheed Martin focus their resources on developing hypersonic missiles for military applications, a small startup named Boom Technology is taking on an entirely different challenge. Their goal? To bring back supersonic passenger travel, pushing the boundaries of civilian aviation in ways not seen since the Concorde's retirement in 2003. Boom's ambition is staggering, especially considering the enormous financial and technical hurdles they face. Developing a supersonic aircraft is an incredibly complex and expensive endeavor, typically the domain of large corporations or government-backed projects. Yet Boom, with its team of just over 200 employees, is attempting to compete with industry titans boasting workforces in the hundreds of thousands. The stark contrast between military and civilian applications adds another layer of complexity to Boom's challenge. While defense contractors can rely on generous government funding and less stringent noise regulations, Boom must navigate strict commercial aviation standards and find ways to make their technology economically viable for airlines and passengers alike. The risks for Boom are significant. The history of aviation is littered with failed attempts to revolutionize air travel, and the company is betting everything on the success of their XB-1 demonstrator and subsequent Overture airliner. However, the potential rewards are equally massive. If successful, Boom could disrupt the long-haul travel market and potentially become a major player in the aviation industry. So how does a small startup plan to compete with aerospace behemoths? Boom's strategy hinges on a combination of innovative design approaches and strategic partnerships. By leveraging advanced computer simulations and wind tunnel testing, Boom has been able to iterate and refine their designs rapidly and cost-effectively. They've also partnered with established aerospace suppliers to access cutting-edge technologies and manufacturing capabilities. This approach has allowed Boom to make significant progress with the XB-1 demonstrator, which serves as a proof of concept for their larger Overture airliner. The XB-1's design incorporates several innovative features aimed at overcoming the challenges of supersonic flight. But what exactly are these features, and how do they work? To answer that, we need to take a closer look at the technical details of this remarkable aircraft. Imagine an aircraft that can fly from New York to London in just 3.5 hours. It sounds like science fiction, but Boom's XB-1 aims to make it reality. Yet as we examine its innovative design, a crucial question emerges. Can this small startup truly overcome the immense challenges that have grounded supersonic passenger travel for decades? The XB-1's striking appearance is more than just aesthetic. Its 17-foot wingspan and swept wings are carefully engineered to minimize wave drag, a significant hurdle in supersonic flight. Powered by 3 General Electric J85 engines with variable geometry air intakes and exhaust pipes, the XB-1 is designed to produce the immense thrust needed to counteract supersonic drag. But achieving supersonic speeds is only part of the challenge. The XB-1 must also withstand the extreme temperatures generated at such velocities. To address this, Boom has constructed the main body from a combination of lightweight composites, titanium, and stainless steel. The leading edges are made from materials capable of enduring temperatures up to 1,300 Fahrenheit, ensuring the aircraft's structural integrity at high speeds. Despite these innovations, skepticism persists among industry experts. Many question the XB-1's ability to achieve and sustain supersonic speeds while managing the associated sonic boom and drag issues. These concerns are not unfounded, given the complex history of supersonic passenger travel. However, Boom continues to push forward, incorporating cutting-edge solutions into their design. One such innovation is the thermoregulation environmental control system, which ingeniously uses fuel as a radiator to manage cabin heat. This approach demonstrates Boom's commitment to addressing the multifaceted challenges of supersonic flight. Recent tests have shown promising results for the XB-1. During its 7th subsonic flight, the aircraft achieved a personal speed record of 629 mph, approximately Mach 0.82. demonstrating structural stability at high speeds. This milestone, while impressive, still leaves the crucial test of breaking the sound barrier ahead. The XB-1 has also completed a series of integrated ground and taxi tests, receiving its airworthiness certificate from the FAA. These achievements mark significant progress in Boom's roadmap toward supersonic passenger travel. As the company prepares for the XB-1's first supersonic flight, the aviation world watches with a mix of excitement and skepticism. The success or failure of the XB-1 will have far-reaching implications for the future of air travel. If Boom can overcome the technical, regulatory, and economic hurdles, we might be on the cusp of a new era in aviation. But the path to supersonic passenger travel is fraught with challenges, and only time will tell if the XB-1 will soar into the history books or join the long list of ambitious aerospace projects that failed to take flight. From the Wright brothers to Chuck Yeager, aviation history is defined by moments when the impossible becomes reality. Now, Boom Technology aims to write the next chapter. But as they race towards their supersonic goal, a daunting challenge emerges. Can they navigate the complex web of technical hurdles and regulatory red tape in time for their 2024 Mach 1 flight? The significance of Boom's planned Mach 1 flight in late 2024 cannot be overstated. It represents a critical milestone in the company's quest to revive supersonic passenger travel. Before this historic moment can occur, several crucial steps remain. The XB-1 must complete a series of 10 subsonic flights, with 7 already under its belt. The most recent flight saw the aircraft achieve a personal speed record of 629 mph at an altitude exceeding 25,000 feet, demonstrating its capability to operate at high speeds. However, the path to supersonic flight is fraught with obstacles. Boom faces a tight timeline, compounded by potential technical setbacks and the need for regulatory approvals. The company must navigate these challenges while maintaining its ambitious schedule. The history of supersonic flight is littered with unforeseen complications, and Boom must remain vigilant to avoid similar pitfalls. The technical and regulatory hurdles for supersonic flight are substantial. Boom must ensure the XB-1 can withstand the extreme forces and temperatures associated with breaking the sound barrier. Additionally, they must address concerns about sonic booms and their environmental impact. The regulatory landscape for supersonic flight over land remains complex, requiring careful navigation and potential policy changes. Boom's test flight program incorporates rigorous safety protocols and data collection methods. Each flight provides valuable information on the aircraft's stability and performance, allowing engineers to refine and optimize the design. The company's receipt of an airworthiness certificate from the FAA and completion of an extensive flight readiness review mark significant progress towards their supersonic goals. As the Mach 1 flight approaches, anticipation builds within the aviation community. The potential outcomes are varied and impactful. A successful flight would validate Boom's design principles and bring the dream of commercial supersonic travel one step closer to reality. Conversely, setbacks or failures could cast doubt on the viability of their ambitious plans. The XB-1's progress brings us tantalizingly close to the realization of ultra-fast aircraft. With each successful test, the barriers to supersonic passenger travel diminish. Yet, challenges remain. As we look to the future of supersonic travel and Boom's larger Overture airliner, one question looms. Are we truly ready for this revolutionary leap in aviation technology? While the XB-1 pushes the boundaries of speed, Boom's ultimate goal lies beyond the horizon. The Overture airliner aims to revolutionize commercial aviation, but a pivotal question remains. Can supersonic travel overcome its troubled past to become a sustainable part of our future? Boom's vision for the Overture is ambitious. The airliner is designed to carry between 64 to 80 passengers depending on the configuration and aims to operate on 600 flight routes over water. This could drastically reduce travel times on long-haul flights, potentially transforming international business and tourism. Imagine crossing the Atlantic in just over 3 hours, opening up new possibilities for global connectivity. However, the path to widespread supersonic travel is fraught with challenges. The economic viability of such flights remains a significant hurdle. Boom's preliminary estimates for Overture ticket prices range from $200 to $250 million per aircraft, comparable to the Concorde's prices in the 1990s when adjusted for inflation. This raises concerns about accessibility and whether there's a large enough market to sustain regular supersonic routes. Noise and environmental impact pose additional obstacles. To address these issues, Boom plans to break the sound barrier just above water, minimizing noise impact on land. The company is also developing the Symphony engine, a crucial component of their strategy. This new power plant aims to provide 35,000 pounds of thrust at takeoff for each of its 4 engines, significantly increasing performance compared to the XB-1's engines, while potentially improving fuel efficiency and reducing emissions. Despite the challenges, there's notable optimism regarding market demand. Major airlines like United Airlines and Japan Airlines have already placed orders for Overture aircraft, signaling industry confidence in the concept. This support from established carriers could prove crucial in overcoming regulatory hurdles and securing the necessary infrastructure for supersonic operations. The timeline for commercial supersonic flights is ambitious, with Boom aiming for the first passenger flights of the Overture by 2029. However, this goal depends on the successful completion of testing and regulatory approvals, processes that have historically been unpredictable and time-consuming in aviation. As we stand on the cusp of this potential supersonic revolution, we must ask ourselves, is the world truly ready for the return of faster-than-sound passenger travel? The answer will depend on our ability to balance the allure of speed with the realities of economics, environment, and safety. As we've explored Boom Technology's ambitious journey to revive supersonic passenger travel, it's clear that we stand at a crossroads in aviation history. The potential impact of successful supersonic flight extends far beyond faster travel times. It could reshape global business, tourism, and even our perception of distance. Yet this technological leap forward raises important questions. Are we prepared for the environmental consequences of widespread supersonic travel? How will it affect global economies and social structures? And perhaps most crucially, are we willing to embrace such radical change in an industry where safety and reliability are paramount? The XB-1 and Overture represent more than just faster aircraft. They embody our ongoing pursuit of innovation and progress. As Boom races against time and skepticism, the outcome of their endeavor will likely shape the future of air travel for decades to come. What are your thoughts on supersonic passenger travel? Do you see it as an exciting leap forward or a potential step too far? Share your opinions and let's continue this important discussion about the future of aviation.